All right, so where do we start in terms of what this course is all about? So again, for the most part, this is going to be a review, but we're going to start with just kind of some fundamentals. So today, we're going to focus on those first two parts. What is chemistry? What is matter? What happens when these things are transformed? The main topic on Wednesday will be the scientific method, along with units and significant figures. We're going to kind of track the beginning of the chapter. And then the end of the chapter, dimensional analysis, energy, that's the stuff that we'll get to on Friday. So we're going to be in this for about a week. I've actually scheduled next Monday for this module as well, primarily as a kind of cleanup. Let's review and address anything that we might be struggling with today. And that's going to be feedback driven from you. So if you're telling me in the feedback, no, we got this, we can move into chapter 2 next Monday. If the comments are coming back, boy, I'd really love to see a couple more examples of this. I'd like to see more of that. That's what Monday's for. So this calendar that I gave you, there's some flexibility there. And if you read it close, you'll see that there are some days in there where it says we're going to do some reviewing, or we're going to do this, or we're going to do that. And that's feedback driven. You tell me we need to do this, you tell me what we want to work on, we work on it. So starting here then, what is chemistry? Chemistry is the study of matter, its properties, and the mechanisms involved in its changing. Very technical sounding definition. Let's get to the real meat of it. Chemistry is the study of stuff. Physical stuff in particular. Because we know, by definition, matter is any substance that takes up space and has mass. So we know that that's what matter is. If we're getting into the properties of that stuff and the mechanisms involved in those changes, what we're really getting into is pretty much a discussion of anything and everything physical. Everything physical is matter. And chemistry is the study of all of those things. Which is why chemistry is positioned as what is called the central science. Because without an understanding of chemistry, without an understanding of this matter and what it does, it becomes really, really difficult to get into higher level discussions in any of the other sciences. Really hard to have a good discussion about what is happening inside of a cell if we don't know how the components of that cell are made up and how they interact with each other and why the mitochondria does what it does. All the processes there are chemical. It can be really difficult to understand what is going on in the physics world without an understanding of how those matter concepts interact. Yeah, we can talk all we want about the energy and the interactions of those energies, but we can't link that energy to something tangible, something that we can see, feel, and touch. Physics becomes a glorified mathematics class. So it's really difficult to talk about the other sciences without at least having some understanding, some knowledge of chemistry and how it links them all together. So we get into some definitions here. By definition, matter is any substance that has space and mass. Already discussed that on the previous slide. At the fundamental level, matter is made up of atoms. Atoms are the smallest repeating units of a substance that we cannot break apart into smaller, more simpler substances. Now, we will get into what makes up an atom in module number 2. We'll talk about protons and neutrons and electrons and all of that other stuff then. But for right now, we're going to just focus on the atom as just its own kind of entity. That thing that we cannot break apart further. Because we really can't break an atom apart further without destroying its identity as a substance. We also know that atoms, because they are the fundamental building block, when they combine with each other, they can form larger molecules and compounds. We're going to make one note here about this combination. This combination of atoms has to be a chemical combination. Can't be a physical one. And the reason it can't be a physical combination is pretty simple. Physical combination can occur in any amount and can be easily separated. Whereas a chemical combination, because there are bonds involved, it has to be a very specific amount of each. I can't make water with 3 hydrogens. Can't be done. I can't make carbon dioxide with 4 oxygen. Can't be done. If I tried to do something along those lines, I wouldn't have the substance that I'm trying to make. If I make a water molecule with 3 hydrogens and 1 oxygen, it's not water. It's something called hydronium. Hydronium is acidic. Water is not. If I make carbon dioxide with 4 oxygens, it's not carbon dioxide, it's something else. So we have to be very, very specific about how we use our terms and what they mean. If I just have carbon and oxygen together, and they're not even chemically combined, that's something completely different. That's not a mixture. All right, let's get into our first discussion question here for today. We have discussed the definition of matter. We know that's the physical stuff of the universe. If I look at every single thing that is physical, I'm going to have a really hard time trying to pull together and describe it. Because there are so many different ways that I can describe matter. So what I want you to do, take a couple of minutes here. What are some ways that we can put matter into groups? Now, a couple of things to understand. First of all, there's no wrong answer here. Second of all, your answers are anonymous up here on the board. So it's going to log for gradebook purposes that you put something down, but for the class, they're not going to see what you wrote. So you don't have to worry about, feeling like you're putting up something wrong, or people are going to make fun of you for saying something that's not correct or is perceived as being like dumb or stupid. None of that matters. We're looking for some ideas. So most of you fell into this category. Solids, liquids, and gases, easy way of classifying matter. What we need to understand about solids, liquids, and gases as far as classification is concerned is that the properties that we associate with each of them have a lot to do with how they are arranged and what they're doing with each other. So in solids here, we can see that the molecules are touching. And that the arrangement of the particles is very important. Straight lines, very specific patterns. As a result of this, we talk about molecules, solids having a defined shape. And a defined volume. I have no idea what's going on with this. And I was working with the historian and I was drawing perfect circles. Now I can't even write the letter E. Okay, so that's the solid. Solids have defined volume, defined shape. Molecules are liquid. We see that the molecules are still touching, but we have to that touching of the molecules is going to keep us to have a defined volume still. But we're going to lose that definition in shape. Thirdly, with gases, we see molecules are not touching and they are disordered still. In fact, they are very disordered. And as a result, we're not seeing a defined volume or a defined shape in gas. So what does this mean? Well, because a solid is going to be very, very defined in terms of its volume and shape. It's going to be rich. If you have a very set volume, if you can have that defined volume, you can measure the volume of the liquid pretty easily. Graduated cylinders, beakers, burettes, you name it. The shape is undefined. It's going to fit into whatever container we put it in. Gases, on the other hand, undefined volume and shape, they are going to automatically expand to whatever container they're in because they are so disordered, and they are going to take on whatever shape the container is as well. When it comes to phase transformations, there are 6 in total. We are the most familiar with the one in the middle. Melting, when we have solid turning into liquid, freezing when a liquid turns into a solid. Condensation when a gas turns into a liquid, vaporization when a liquid turns into a gas. Now, one important point of note here that I want to have everyone be aware of, and it's this. This is called vaporization, not boiling. Why don't we call it boiling? No, but you're not far off. Go ahead. Getting closer. What you say? Not quite. It's same thing. Okay. Boiling is a very specific term. Boiling occurs when the vapor pressure of a liquid is equal to the atmospheric pressure. That is what's called the boiling point. Now, the reason we consider 100 degrees Celsius as the boiling point of water is because that is the temperature where we see this phenomenon occur at atmospheric pressure. But what we have to understand, boiling and all of these phase changes for that matter are a 2-factor process. They are temperature dependent and they are pressure dependent. Now, when we get to intermolecular forces in module 9, we'll get into this in way more detail than you would ever care to know. But for right now, I want to kind of plant that seed for you because we have to understand vaporization occurs without boiling. And we know this process. We just never think about it this way. I'll give you a perfect example. It rained this morning. When I got here, parking lot was covered in water. Not much, but it was wet. There were also puddles of water in the parking lot. I look out there now, I don't see any of that. What happened to the water? It evaporated, that's right. Does evaporation occur at the boiling point? No. The concrete out there didn't turn into 212 degrees Fahrenheit, 100 degrees Celsius. It vaporized without that. Vaporization can occur without boiling. The process called vapor pressure, we'll get into that again near the very, very end of this semester-long journey through chemistry. But I want to kind of put that out there now because it's one of the easiest things to get wrong. It's one of the earliest things we want to try to remember. All right, one last question, and then we will close it out for today, and we'll pick up on Wednesday. All right, so couple of things. First of all, we didn't get quite this far. I got this far in the morning. I didn't get to here. We talked a little bit more about some other stuff. We will pick up with that on Wednesday. However, you might see a couple of items in the active homework about classifying by composition. So I would encourage you to look at the PowerPoint that I'm going to upload this evening if you want the full version of the notes there. If you're having trouble with what's in the homework assignment. But as is always going to be the case, the last question of the day is always going to be the stoplight question here. So a word of caution to you, if you haven't seen this question yet, don't put your stuff away.